Let's take a look at the following problem. Investment example. An investment increases from $187 to $1,270 in a period of 7 years. What is the annual rate of return? So to answer that, we can use this formula. R is, we'll take the new amount, divide by the old amount, and do 1 over n for the number of years or whatever kind of incremental equal amount of time. N represents equal amounts of time, and then we have to minus 1. This actually comes from the compound interest formula, and it's solving for the rate in the compound interest formula. So we'll just go directly to that formula and plug in the appropriate value. So the new value, that's the 1270. The original or old value, that is the 187. Here we have equal amount of time, equal steps of time of 7 years, so it's 1 over 7. So whatever this amount of time is as long as it's equal amounts of time, you'll get a rate of growth in that corresponding time increment, right? So here it will be yearly return because the 7 represents years. And then the minus 1, it basically just calculates the amount of change from 100%. Okay, and then this definitely would be something for the calculator, so we'll just type that in. So in this calculator, I'll type 1270, I'll divide by 187, and then I'll use an exponent. In this calculator, the exponent goes right up there into the exponent position when I hit that button. But if you don't have that, make sure that you use parentheses to make sure that the 1/7 is the exponent, and you don't do something like divide to the power 1 and then all divide by 7. So you have to make sure that the 1 over 7 is actually in the exponent, might require parentheses. So it's already in the exponent position, so I can just type 1 divided by 7, and then the minus 1, and I get like something here roughly. It says 2 decimal places, round to 2 decimal places, and then use that value in the next calculation. So we'll say that's approximately 0.314 and then maybe 7 and an 8 if I round it off. But it said to 2 decimal places, but I'm thinking in the final answer I should write it to 2 decimal places. And this is just the R value, not as a percent. So this would be equivalent to like 31.478%. And so really rounding in my final answer to 2 places, I want these 2 places here, so I'm going to say 31.48%. So let's use that. Now, continuing, it says, suppose that after it reaches that 1270 amount, the investment continues to grow at the same annually compounded rate, 31.48% every year. This is really incredibly high growth, particularly for that long a period of time. So I would expect the final amount to be really big, growing 31%. Roughly 31% every year for 9 years. What would it be? So now to answer this, what's the final amount after 9 years of 31.48% growth? We'll go back to the compound interest formula. So I'm saying after it reaches that 1270, it continues to grow at the same annually compounded rate for another 9 years. So starting with 1270 and then carrying on for 9 years. So what we'll do here is we'll use that compound interest formula with annually compounded 31.48%. So my future amount is based on my principal amount, 1 plus R over N NT is the general formula for compound interest, where you have a rate R and a frequency of compounding of N, and here I'll just take that N to be 1 and the annual rate to be 31.48%. And the starting amount to be 1270. So there's my starting amount, 1 plus a rate of 31.48 annually compounded for a period of 9 years. In other words, we're taking 1270 and we're increasing it by about 31% every year, right? 1.3148 for 9 years. 31.48% growth every year for 9 years. So it looks like that. Putting that in the calculator, I would say 1270, and then I do 1 0.3148 and raised to a power 9. So 14,000. 14,912 and about 17 cents. So that should be the answer for that one. Okay, and that checks out. So there they are. Hope this was helpful.